This is Module 15, the application layer of the Introduction to Networks Cisco Academy course version 7.0. The application layer of the TCP/IP model encompasses application, presentation, and session layers of the OSI model. As we can see here, the top three layers of the OSI model, session, presentation, and application, are equivalent to the application layer of the original TCP/IP model. At application, we provide services to applications. In itself, it is not an application, but it provides those necessary services to applications that we may have so that they can efficiently and effectively communicate with other computers. Some of the protocols that we provide services for would be domain name system, hypertext transfer protocol, simple mail transfer protocol, post office protocol, dynamic host configuration protocol, file transfer protocol, and internet message access protocol. The application layer mainly provides us with the interface to go between our programs running in an operating system and the network connection. The presentation layer has three primary functions. It formats on how do I present the data. Is the data going to be encrypted? Is it going to be compressed? Anything about how we present the actual data. The session layer, which is layer 5 of the OSI model, but still in part of the application layer of the TCP/IP model, it creates and maintains the dialogues between the source and the destination applications. It handles the exchange of information to initiate dialogues, keep them active, and to restart sessions that are disrupted or idle for a long period of time. As we can see in the diagram, some of the protocols that are at the presentation layer would be Masstroka Video, Motion Picture Expert Group, or MPG, QuickTime, Graphics Interchange, Joint Photographic Experts Group, Portable Network Graphics. The TCP/IP application protocols specify the format and control information necessary for many of these common Internet communication functions. The application layer protocols are used by both the source and destination devices during a communication session. As explained earlier, the application layer provides the interface to go to the programs that are running on the operating system. So it becomes a necessary part of those programs conversing with another computer or network. For the communications to be successful, the application layer protocols that are implemented on the source and destination host must be compatible. Some of the ones that we see here, such as DNS, it is available in both TCP and UDP with a port number of 53, and it translates domain names such as cisco.com into an IP address. DHCP for host configuration uses UDP for the client of 68 and server 67, and it will dynamically assign an IP address to be reused when no longer needed. Web traffic, or HTTP, as well as HTTPS, would use port 80, port 8080, or 443. And this provides a set of rules for exchanging text, graphic images, sound, video, and any other multimedia files on the World Wide Web. The most simple type of network is a simple peer-to-peer. This could be when you link your phone to your computer, or a client going to a server. It is just a one-to-one connection. It may take place over a larger network, or it could be as simple as hooking up a wire between the two systems. The client and server model are considered to be in the application layer. The most common client-server model that people experience would be downloading web pages from the internet. The server being the company or provider's service, and the client being the host computer. In the client-server model, the device requesting the information is called a client, and the device responding to the request is called a server. Application layer protocols describe the format of the request and the responses that are then made between the clients and the servers. Here, peer-to-peer is a very simple way of connecting two computers together. As in the diagram, they may connect through a switch, or it could be as simple as a crossover cable between the two peers. In the early days of networking, this was very common in that printers would not be network connected, and they may be attached to a print server client. This client would then allow access to the printer by other machines. In a peer-to-peer or P2P network, two or more computers are connected via a network and can share resources such as printers and files without having a dedicated server. Every connected end device known as a peer can function as both a server and a client. One computer might assume the role of server for one transaction while simultaneously serving as a client for another. The roles of client and server are set on a per request basis. There are many programs for file sharing that fall into this category of peer-to-peer, possibly the most famous being Napster for music sharing. There are many others such as BitTorrent. At some point, your computer may be the client downloading music or other types of video from a server, or in another instance, your computer or your host may act as the server to fulfill a request by a different client and provide music sharing. You must remember that all copyright laws must be maintained. A peer-to-peer or P2P application allows a device to act as both a client and a server within the same communication. Some peer-to-peer applications may use a hybrid system where each peer accesses an index server to get the location of a resource stored on another peer. This is very common in music sharing, but again, violations of copyrights must be considered. In a case like this, a client may wish to find some particular piece of music. They would go to an index computer that would identify the closest computer to them where that particular piece of music could be found. They would then go to that server, because now it acts as a server, to download the file. Here are some of the common peer-to-peer applications. Each computer in the network that is running the application can act as a client or a server for the other computers in the network that are also running the application. The most common being BitTorrent, Direct Connect, eDonkey, and Freenet. Remember, it is only acceptable to exchange free, uncopyrighted data. One of the things when exchanging data that you must remember is that when you use a peer-to-peer program, that would take priority over your network connection. So that if somebody is downloading information from you, your own use has to wait. Web and email protocols are extremely important. Today, when in many companies the standard communication practice is email, these become critical. First, we will talk about hypertext transfer protocol and hypertext markup language. When a web address or uniform resource locator is typed into a web browser, the web browser establishes a connection to the web service. The web service is running on a server that is using either the HTTP protocol or HTTPS if we want it to be secure. The first step is the browser interprets the three parts of the URL. First, the protocol, as in this case, HTTP. Then the actual server name, such as www.cisco.com. And then finally, the specific file name that is requested. In this case, it is simply an index. Step 2, the browser would then check with the name server to convert www.cisco.com into a numeric IP address. You must remember that the computer does not understand the name. They work simply by IP address. It uses that IP address to connect to the server. The client will then initiate an HTTP request to a server by using a GET command. So it will say, get a particular file from the server. In response to the GET request, the server will then send the HTML code for that particular web page. Once the web page has been downloaded, the connection is severed. At each time a selection is made on a web page, the connection is reestablished to get the data. Step 4, the browser will decipher the HTML code and formats the page for the browser window. HTTP versus HTTPS. HTTP is a request response protocol that specifies the message types used for that communication. The three most common message types are GET, POST, and PUT. GET, as we previously discussed, is a client request for data. A client, via a web browser, sends the GET message to the web server to request HTML pages. POST would upload data files to the web server, such as filling out a form. Finally, PUT would upload resources or content to the web server, such as an image, such as this video is uploaded to the web server. HTTP is not a secure protocol. For secure communication sent across the internet, HTTPS should be used solely. Email protocols use mainly three protocols: SMTP, or Simple Mail Transfer Protocol; Post Office Protocol, or more popular version, the latest being POP3; and finally, IMAP, which is used for clients to receive mail. As we can see in the diagram, the sender uses SMTP to send an email to their mail server. If it has to go from one mail server to another, such as a Gmail account going to an AOL account, SMTP would also be used. To download the email, the recipient would use either IMAP or POP3. The difference being, POP3 will download the file from the mail server so that it resides on the local system. IMAP will make a copy of the file from the mail server so that it still resides on the mail server until purposely deleted there. This would allow a client to change to another computer and get the same email because it would reside on the mail server and not on the local recipient where it was first downloaded. When a client sends email, the client SMTP process connects with a server. The SMTP process is on a well-known port of 25. After the connection is made, the client attempts to send the email to the server across the connection. When the server receives the message, it either places the message in a local account if the recipient is local, such as somebody from Gmail going to somebody else on Gmail, or if the recipient is not local, it will forward the message to another mail service, such as AOL. The destination mail server may not be online or may be busy. If this is the case, the SMTP protocol will spool the message so that it will be uploaded to the remote mail server at a later time. Mail must have in its format a message header, the recipient email, and the sender email address. POP, or POP3, is used by an application to retrieve mail from a mail server. When mail is downloaded from the server to the client using POP or POP3, the messages are then deleted on the server. The server starts the POP service by passively listening on TCP port 110 for the client connection request. When a client wants to make use of the service, it sends a request to establish a TCP connection with the server. When the connection is then established, the POP3 server sends a greeting. The client and POP server then exchange commands and responses until the connection is closed. In these commands and responses would be the user's password and username. Since POP does not store a message, it is not recommended for a small business that needs a centralized backup solution. IMAP is the second protocol that we talked about as far as downloading mail. Unlike POP, when the user connects to an IMAP server, copies of the messages are downloaded. These go into the client application. The original messages, although, are kept on the server until they are manually deleted. When a user decides to delete a message, the server synchronizes that action and deletes the message from the server. IP addressing services. The most common is DNS, or domain name service. Domain names were created to convert a numeric IP address into a simple recognizable name. This is for human use. The computers, or the hosts and servers, still use the IP address. A fully qualified domain name such as HTTP, www.cisco.com are much easier for people to remember than an IP address such as 198.133.219.25. The DNS protocol defines an automated service that matches resource names with the required numeric network address. It includes the format for queries, responses, and data. This is one of the easiest things to attack a system. You may put in a request to go to a particular website, but unless you know the actual IP address, it is possible to get a phony address sent back to you from a DNS server. It could be a phony DNS server, or it could be attacked in transit. So when you make a call to go to some financial website, unless you are very careful, you may not be going to the financial services that you thought you were. In the DNS message format, it stores different types of resource records, and these are used to resolve names. These records contain the name, address, and type of record. Some of the records that you may be familiar with would be coded as an A, and this would be an end device IPv4 address. An NS would be an authoritative name server. 4 A's indicate that it is an IPv6 address, normally pronounced as Quad A. MX is a mail exchange. When a client makes a query, the DNS server process first looks at its own records to resolve the name. If it is unable to resolve the name locally by using its stored records, it contacts other servers to resolve the name. When a match is found and returned to the original requesting server, the servers in place will store that DNS so that the next time it is requested, it will be a local event rather than having to go out to a remote server. It normally takes about 7 days for a new domain name to be available throughout the world. The DNS message format consists of a question and answer, as well as authority and any additional information for all types of client queries and server responses. The question may be the question for the name server. An answer would be a resource record answering the question. The authority that it comes from would be an authority guaranteeing that it is who it says that it is, and any additional resource records holding additional information. As we can see here, we actually have a hierarchy of domains. DNS will use a hierarchical system to create a database to provide name resolution. Each DNS server maintains a specific database file and is only responsible for managing name to IP mappings for that small portion of the entire DNS structure. When a DNS server receives a request for a name translation that is not within its DNS zone, the DNS server then forwards the request to another DNS server with the proper zone for translation. Some of the top level domains would be .com, .org, .au. Some of the other ones that you may see, .jp for Japan, .sg for Singapore, .eu for the European Community. We can use the NSLOOKUP command, and this is available in a computer operating system using the command prompt, where we would type in NSLOOKUP. And in the computer operating system, it is a utility that allows a user to manually query the DNS servers configured on the device to resolve a given host name. The utility can also be used to troubleshoot name resolution issues and to verify the current status of the name servers. When the NSLOOKUP command is used, the default DNS server configured for your host is displayed. The name of a host or domain can be entered at the NSLOOKUP prompt. As we can see in the diagram, simply typing in NSLOOKUP, it tells us that our default server is dns-sj.cisco.com, which is that address 171.70.168.183. After entering there, if I ask for www.cisco.com, it will tell me, again, the DNS server, the address, the name, the IPv6 address, any kind of aliases. As we can see at the bottom, cisco.netacad.net. DHCP is the most popular protocol to assign an address or lease an address to an end device. Many devices do not use DHCP, such as printers or servers, because those IP addresses must be static. Otherwise, you would not know where to go to reach the server or the printer. The Dynamic Host Configuration Protocol, or DHCP, is for IPv4, and it's a service that automates the assignment of IPv4 addresses, subnet mask, gateway, other options, lease times, many things that could be assigned to our host. It is considered dynamic addressing compared to static addressing. Static addressing is manually entered IP address information, such as on a printer. When a host connects to the network, the DHCP server is contacted and an address is requested. The DHCP server chooses an address from a configured range of addresses called a pool and assigns or leases it to the host. Many networks use both DHCP and static, as for general purpose hosts would use DHCP, but printers, servers, and things that must maintain a single address would be statically addressed. We also have DHCP for IPv6 or DHCP v6, and this provides similar services for IPv6 clients. DHCP for v6 does not provide a default gateway address, and that can only be obtained dynamically from the router advertisement message. And that will normally be the link local address. DHCP is a four-step process. When a client is booted up, after the operating system comes up and starts running, it will send out a DHCP discover message. This is a broadcast message and will stop at the router. The router may turn this into a directed broadcast to a DHCP server if it is configured. There may be one or more DHCP servers on a network so that there is backup. The server will then make an offer, and in the offer will be the IP address, the subnet mask, the domain name, DNS, as well as a lease time. The client still does not have the rights to use this address. It must send back a DHCP request message and identifies the explicit server and lease offered to that client. If the client receives multiple offers, usually the first offer is the one that would be returned. Sometimes the server may have made that offer to more than one client and it has already been taken. At that point, the client must request another offer. Once the request is received by the server, if the address has not been assigned to another host, the server will send a DHCP acknowledgement. That authorizes the client to use that IP address for a particular time period. If the offer is no longer valid, meaning that the server has already assigned it to another system, it would return a DHCP not acknowledged message, and the client must then use the DHCP discover beginning again. DHCP for v6 has a set of messages that is similar to those for DHCP v4. DHCP v6 messages are solicit, advertise, information request, and reply. One of the things that we must be careful of on a network, a threat actor may set up their host computer as a server so that they can direct an unsuspecting client to their own DNS server and direct them where they want to go. When configuring switches, one of the things that we would look for is that the discover message, which I will call 1, should be going into the port connected to the host. The offer, which I will call 2, should be coming from the server into the port. To configure this, we would tell the switch that this is a trusted port. The request, which we will call 3, again goes into the switch, and the acknowledgement should be coming from the server into the trusted port. Another host port as in this case with our bad actor, would be sending to and for in, because they would see the original broadcast as a broadcast goes to everyone. Once the switch recognizes that this is not a trusted port and should not be seeing either the offer or the acknowledgement going in, it will automatically shut down the port. This is a process that we turn on the switches referred to as DHCP snooping. There are many types of file sharing services. FTP, or File Transfer Protocol, is one of the most common. It uses two ports, 20 and 21 of the TCP protocol, and it was developed to allow for data transfers between a client and a server. An FTP client is an application which runs on a computer that is being used to either push or pull data from an FTP server. The first step in the process, the client will establish the first connection to the server for control traffic using port 21. The traffic consists of the client commands and server replies. The client will then establish the second connection, and this is TCP port 20. You'll notice that we use TCP so that we have a reliable communication, and any parts of lost data could be retransmitted. Trivial File Transport Protocol uses UDP, so the entire file would have to be retransmitted. Therefore, for large file transfer, FTP is the preferred method. Step 3 would be the data transfer can happen in either direction. Either the client can upload data to the server, or the client can download data from the server. The download is pulling data, while the upload is pushing data. SMB, or Server Message Block, is a protocol that runs on the Windows operating system. It is a client-server request-response file sharing protocol. Servers can make their own resources available to clients on the network, such as putting it into a shared folder. 3 functions of SMB messages. They start, they authenticate, and terminate the sessions. They control the file and printer access. And they would allow an application to send or receive messages to or from another device. But unlike FTP, or file sharing, clients establish a long-term connection to the servers. After the connection is established, the user of the client can access the resources on the server as though the resource is local to the client host. This concludes Chapter 15.